The idea is to talk about convex functions, which are quite important, very convenient to work with. So this is a convex function. You can see the function fx, which is convex. What is very important about the convex functions that they have a global minimum that you can get to. In optimization, for example, you know that you can get using convex function to a global minimum and not get stuck in a local minimum if you're looking for the minimum. So convex is very convenient and important in optimization. If you can work your problem and make it as a convex function, so you can apply algorithms that can get to the global minimum to the optimal point and not get stuck in some local minimums or other things. So how a convex function is defined? A convex function is defined, as you can see, with this equation that in every point, if you take a line and cross it using points from the function, the line that you cross will be above the function. And this is defined by this two formulas and an inequality. So the line between 2 points, x1 and x1 and x2, is defined as theta, which is above between 1 and 0, the value of the function in x1, which is fx1, plus the value of the function in x2 multiplied by 1 minus theta. Again, theta is between 0 and 1, which is the weighted sum of those two values of the function, which give us this line between the points. And convex function, by definition, every line between 2 points in the convex function is above the function. This is the definition. Namely, if I take all the points between these 2 points in on the function, this value represent the values between the 2 points x1 and x2. Always this value will be less than or equal to the value of the line between these 2 points. So the line between 2 points of the function is always above the values of the function between these 2 points. And this is the definition of a convex function. And you can see here a convex function. For example, convex function could be x squared. Convex function can be e to the, I don't know, x. We will see some example, a parabolic function. Yes. So let's see a convex function. This is the inequality I talked about. This represents the value of the function between 2 points, x and y. This represents the line between 2 points of the function x and y. So the line is always above or equal the values of the function between the 2 points. And this is what defines convex function. And you can see the formal definition for a function in the real numbers to the real numbers is a convex if for every 2 points on the real numbers on the function and a value between 1 and 0, this holds, which means what I told you. For example, you can see the linear function, a quadratic function, exponential function, x to the squared, and properties. So there are some properties that we can use to know if a function is convex. So if I take two convex functions and get the sum of them, I will get again a convex function. Weighted sum, non-negative weighted sum of convex function is again convex, and if f is convex, so for a matrix A and vector B, this holds, and this is again a convex function. Okay, so the most important thing is that if you sum convex function, you will get a convex function. Application optimization problems, where we talked about convex optimization problems, which you will have very convenient getting to the minimum and the global minimum and not get stuck in a local minimum or something like this. So it can be used in machine learning, and if you have a convex function, you can look for the minimum, like in, I don't know, looking in loss function with it, which is convex. When we are taking the when we are taking the function and making it convex, we can get to a global minimum. Okay, so this was about convex function. Maybe this formula, this inequality, is the most important thing in this representation. Represent how convex function behave and looks. Uh, the blue is the convex function. Thank you very much. If there are any correction, please correct me. If there are any mistakes, I'm sorry. This was about convex function. and that's it. Thanks, thanks for this for the image.